The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, for number 4, we want to find whether the series converges. Let me write this out for you real quick. So we have the series as n goes from 1 to infinity of 3 over 5 root n plus n. So we just want to know if this converges and by which test. So this function looks similar to a p-series, kind of. And in that case, we want to use the comparison test. So we need to figure out what we're going to choose. We know that in a comparison test, or a p-series test, if n, the power on the denominator is 1, we have divergence. We have n plus something with the square root of n. So consider the possibility that you had n plus something that also had an n. You would just add those together and have a coefficient. The denominator would still just be n, which diverges. So we should expect that this will diverge. So we need to prove it by comparing it to a relative harmonic series. So let's compare our series to kind of what I was just saying there before. Let's say we had the series where it was just n instead of square root of n. This series right here is definitely larger because this denominator is always going to be smaller than this one. Square root of n is always smaller than n for n greater than 1, because obviously at 1 they're equal. Remember though that when you're doing a comparison, it only has to be true for large n. And for large n, this is definitely smaller than that. Meaning this whole denominator is smaller than that denominator, and if the denominator is smaller, then this one is larger. So if we can show that this diverges, this definitely diverges by comparison because this is larger. So let's look at this function here. This is 3 over 6n, if we combine the 5n plus the n. That's 1/2 times 1 over n. If we do this, sorry, this should be series this whole time. So we can say here that n, this series definitely diverges. It's a harmonic series times 1/2. The times 1/2, if you have a constant in front of it, as long as it's not 0, that doesn't change the convergence or divergence here. So we get that this diverges. Since this series diverges and this one's larger than it, this series definitely diverges. You can see though that for n equals 1, these two are equal. For any n greater than that, this function is definitely always smaller. So remember that it doesn't need to be true for every n, it just needs to be true for n greater than some arbitrary number, which in this case is just 1.
Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.